Hey, hi. In this video, I'm going to show you how to use Cast AI, which is a cloud optimization platform for Amazon EKS cluster cost optimizations. As you see in this PPT, here my main aim is how we can integrate Amazon EKS cluster with the Cast AI, which is a SaaS product, which will help us to do the optimization at the cloud level. That is, especially Kubernetes cost optimizations. Yeah. So here, I'm going to show you like how we can integrate Amazon EKS cluster, and then finally we can leverage the AI capabilities of Cast AI, which will help us to optimizes the cost. Okay. So as you can see in this PPT, let's say that you have spinned up a cluster at your own estimate, but at the end when you deploy your application, we came to know that that you are actually over provisioned the resources, which is actually burning your dollars. Okay, so in such cases, the Cast AI is a tool or a SaaS product which will help you to optimize your cost based on its own analysis. Okay, so it has a backend artificial intelligence which will help you to analyze and then finally give a result of what are the ways that you can use to optimize the cost. Okay, something like this. Yeah, if you see in the case, in the initial case, you have provisioned a cluster with the cost estimation of $414 per month. Yeah. Then let's say that you have opted a Cast AI a service on your EKS cluster. Then in that case, that a service can help you to analyze your complete cluster, and it will give you an advice saying like so not only advice, it does also help you to restructure your Amazon EKS cluster so that it can save the the dollars. Okay, so for example, earlier it was $414 per month. Then if you can optimize as per the suggestion from the Cast AI, you can save the dollars up to 138 after certain analysis. Yeah. All right, that is a specialization of this Cast AI platform. So this is as I said, this is a SaaS platform. So I'm going to show you like what is a Cast AI, how does it looks. If you go to the Google and search for Cast AI, you're going to see there is a link called https://cast AI. So for this demo purpose, what I did is I have created my own account at the cast.ai. So for that purpose, what I do is I'm going to go and hit on the login. I have already have an account, so that's the reason it is redirecting me to a page where I have already logged in. If you don't have an account, you can still create an account with using your Gmail addresses or with using your own enterprise addresses. Yeah. So at the rest, once you log in to your account, so this is how it shows. So by default, it also shows you the the demo cluster. You see, so there is a demo EKS cluster they have already integrated with us, and it actually the dashboard of that particular the EKS cluster shows like a very amazing one. So as you see here, it clearly gives you like the how much dollar it has saved for you, and there is a potential saving also been shown here in this page. Yeah. So on this EKS cluster, which they have integrated as a demo purpose, they say that it has a tendency that you can save up to 89%. That is amazing. Yeah. So likewise, if you can explore each of the components, you're gonna get a really very depth insights. So not only it just gives you insights, it also provides you capability where you can where this tool itself can help you to restructure your or optimize your EKS cluster in such a way that you're gonna realize that it has changed the estimation of the dollars from high value to optimal value. Yeah. So that's the reason we have a couple of options here, that is dashboard. So this is the this is the first page where you can see the details about your EKS cluster. Not only EKS cluster, it does also supports Azure, GKE, OpenShift. Yeah. So it also supports multiple other Kubernetes cluster as well. Yeah. So here, as we see, the cluster details have been shown, nodes have been shown, pods are been shown. Yeah, it shows the complete resources, right? And we're gonna show the cost monitoring. So if you go to cost monitoring, you're gonna realize so how much cost you are spending per monthly, per average. Yeah. So all those data will be given, and you're gonna, if you want to drill down, you can also drill down at the workload level, saying like on your EKS cluster you have a nodes, on nodes how much you are expending. Within the nodes you have the pods, right? So on the pods, how much each pod is consuming. So not only parts, the outer layer, that is the namespace. So how much namespace is also consuming. Yeah, so you can also consider that level of granular, or you can also estimate that level of cost consumption also will be visualized in this one, which is really amazing. I see that this is one of the quite outstanding SaaS product in the market. Then I will go to the available savings. So if you see the available savings, so this is will give you like the possible immediate possible savings that you can achieve with using this Cast AI, the SaaS product. Yeah, then I will go to the node list. In the node list, it also shows the number of nodes that you have provisioned on your EKS cluster or any kind of Kubernetes cluster, and the potential cost that is being consumed, right? And also it gives you a capability that where you can rebalance your cluster or optimize your cluster to save the save the cost. Okay, so I'm going to show you how this will help us in a real time. But at the this is at this is basically at a generic level. In the sense, when you are logging into that cast.ai tool, this is how it looks, right? So for the demo purpose, what I did is I have already created a EKS cluster for the demo purpose. And this EKS cluster creation, it took me 15 minutes. So I have already created an EKS cluster with using the EKCTL utility. That is EKS create cluster. This is my cluster name, that is Cast AI demo. I have used T3.large, which is actually a bit costly nodes. Make a note that this type of node is bit costly. We're gonna take help of Cast AI and see that how does it advise us, yeah, for cost optimization. And I have created a node that is 3. That is basically 3 nodes at the rest, and minimum equal to 2. Yeah. So maximum equal to I have created 3 nodes. Yeah. And then the reason I have used it is US West one, and these are my availability zones. So my cluster is up and running fine. If I can run a command called kubectl get nodes, so it's gonna. So I think I have typed the wrong command, but that is, yeah. So if we type kubectl get nodes, so as you see here, it's gonna return us the number of nodes. Okay, so currently I have 3 nodes. Yeah. So my cluster, I'm gonna take you back to my AWS accounts. So this is my AWS account, and this is for the EKS cluster which we created, and currently it is in up and running fine. If I refresh the its status, that is active and up and running fine. And I have defined what is the infrastructure, the version as well. Now what I do is I'm going to integrate this EKS cluster with the Cast AI and try to leverage the capability of Cast AI and try to optimize the my cluster so that I can save the dollars. Okay, so not only for me, you can for any enterprises who is hosting their applications on the Kubernetes, like managed Kubernetes like Amazon EKS. Yeah, so how does the Cast AI help us? Okay, that's the main aim here. We have just walked through the we have just now walked completely the options of the the demo cluster that they have already integrated. So now let's go and integrate our original cluster. Okay, so for that case, what did I do is I'm gonna click on a button called connect cluster here. Just click on that, and then so here, as I explained, so this Cast.ai, it supports AKS, GK, OpenShift, kubeops as well. So our interest is EKS. Yeah, so I'm gonna go to the EKS, select the EKS and go next. So connect your EKS Kubernetes cluster. So it just what it does is in the next step it will give you a commands, a full of curl commands. If you can run these commands from your terminals, what does happens is from the backend, this Cast.ai tries to connect with establish the connection with the EKS cluster and tries to gather the data from there. Yeah, so that's the basically a step. So what does under the hood, what it happens is it actually install the agent on our EKS cluster, and that agent is helping this Cast AI to gather the information. And once the information is present on the Cast AI side, it does analyzes that data and helps us to optimize the the cost of the platform. All right. So for this case, so since if you remember, if you can see this command, that is curl. So curl is nothing but it's a Linux, right? So I need to use the CMD. Currently I'm in a PowerShell session, so this is PowerShell. PowerShell will not work. So for that case, for Windows purpose, we need to struggle. If you have a Windows system, we will be struggling because Cast AI is oriented towards Linux. The commands that they are showing, it's good for Linux. Yeah. All right. So for that case, what I do is I'm gonna use my CMD for first part of the demo. So if you are I'm going to show you 2 things basically. One is in the first part, how you can leverage the CMD to connect the agent, that is the Cast.agent with the Amazon EKS. Yeah. So for that case, I'm going to set the context of my Kubernetes cluster. First one, I just need to set the context of my AWS CLI running a command called AWS configure. So I have already configured my secrets and the key, so I'm using the same thing. I'm just gonna check the status, that is AWS get AWS STS get caller identity. So once you run this command, it should return something, which means that you have set the command. Yeah, you have set the context. Now this is not enough for Kubernetes, because you need to set one more context, that is kube context, that is kube config basically. Yeah, so we need to set the config of kube config in your session. Then only you can interact with the Kubernetes API server. So this command is specially meant to interact with our Kubernetes EKS API server. So for that case, I'm running a command called AWS EKS update kube config. This is my cluster name. It shows that it has already set the context. All right. So with that note, let's try to connect to the this cluster by running this command. So I'm going to show you this command from the PowerShell. It does not works. I discovered that it works from the CMD. So not only from the CMD, AWS also provides you natively, that is Cloud Shell. You can use the Cloud Shell. But in that case, you must need to install the the kubectl and Helm chart. I'm going to show you that as well in the next couple of seconds. If I run this command from the PowerShell session, it is telling that hey, there is an error. Yeah, so that's something problem here. So for that case, I discovered that command prompt is very good in the Windows, and it is helping us in this case. So I'm just going to hit that. Here you go. So here the curl command is working, and the whatever the syntax that Cast AI provided us, it works. Okay, basically that's the reason it has tried to communicate with it has downloaded the software. Yeah, so nothing but it downloaded that specification file, which will help us to install the agent from the Cast AI repository, and then automatically it has spinned up so many services, right? So if I show you here, it has created a namespace called Cast AI agent, and then it has created a resource quota. It has created a service account. It has created the secret as well. It has created a config map. Then it created a RBAC. Then it did it also did a the cluster role binding. Then RBAC has been authorization has been done. Then again they have done the role binding as well. And finally they deployed two agents with a name like these two. So we're gonna see the parts running in this particular namespace by running a command called kubectl kubectl get parts -n. The namespace is Cast AI -agent. Yeah. So this is the default namespace that Cast AI creates for us in our cluster, that is Amazon EKS cluster. So two agents are up and running fine. Looks like the connection has been established. Okay. So what I do is I'm going to say I have run the script. Then it's going to check from the backend whether we have successfully established the connections. Okay. So what it's doing is it is currently trying to connect with. Yeah. So it's going to take a couple of seconds, and finally it will be connected. Yeah. So if I go back to the to this one, Cast AI. So as soon as the particular command, that is this curl command, gets executed, the backend connection will be automatically done. So it is taking some time, but we can realize that it has already been occurring. It has already started to report. Okay. So if I refresh the console, since I made a delay because I was showing you the agent's namespace, the configuration that command has done on our EKS cluster, right? So if you see here, it has established a connection. Okay, that's the reason it is now showing us the cluster name. Okay, so which got connected, that is Cast AI demo, right? So that is my cluster name. So Cast AI demo is my cluster name, and that cluster is now got connected, and you see that data fetching is very fast, right? As soon as it got connected, it started to gather the information, and so everything got like a magic. So if I go back to the Cast AI again, back to the original pane, if I go back to the settings, if I go to settings, yeah, settings. All right. So okay. So earlier it was so what happens is, if I can understand correctly, so basically when you have an account which is a default account, and if it does not has any kind of Kubernetes cluster been reporting there in your account, then by default it will show you the demo cluster, which Cast AI itself has populated for us learning. If let's say if you have made another clusters connected on this cast AI, then automatically the options will be shown from that particular clusters. Okay, so here you go. So as I was showing you in the previous cluster, so if I go to the all clusters, the current cluster which we have connected is our Amazon EKS cluster. So if I expand this one, here you can see that so currently this is my cluster, that is EKS cluster. And in this one, so as I said, the data collection is very fast, and it has gathered all the information, and it has populated the data like in a magic. Yeah. So the dashboard. Okay. So there are a couple of options here. That is, a dashboard is like a summary of your Amazon EKS cluster. It gives you complete data, including the cost estimation as well, or cost related information as well. Then it has a cost of monitoring as well. Available saving data will also be populated. Then you can see the security and the security report as well. Okay, so there are a couple of options are there, which we're gonna explore in this video, right? So first one, in the dashboard. So as you see here, the cluster details. Okay, so this is the Kubernetes provider is the EKS. The reason is US West one. That is sorry, that's Oregon, and then the connected is it's connected about 3 hours ago. So basically, it has, so why it is retrieving this data is, if I remember correctly, so basically I have already did a hands-on session before recording this video. At that time I created a cluster with the same name basically. That's the reason it is telling that maybe this could be something to enhance from the cast AI, I can say. Yeah, so basically it should not show like this, because each EKS cluster connection is unique. Yeah, it's not like that since I have created an Amazon EKS cluster with the same name, it should not say me that it has connected 3 hours ago, right? All right, so but under the hood so you see the cluster ID, it should be different. So currently it is again refreshing the data. Maybe this data get refreshed in a couple of minutes. So and then this is our cluster ID, that is local to the cast AI. And then here you can see that currently it shows it has 3 nodes, and then the total pods running in the cluster is 10. We're gonna show that in detail down the line when we explore the cost one. Then in this EKS cluster, it says so how much CPU, how much the memory that we are using, everything will be provisioned and everything will be visualized here. So it shows how much memory we are consuming, everything. So basically these CPU and memory graphs will be shown here. By default it has option of 23. You can basically this is just a summary of your complete cluster. Now let's go to our main aim, right? That is, how do we optimize our cluster cost, right? So if I go to the cost monitoring, there is a so it's another option through which you have multiple options to explore the cost of your cluster. So on the cluster, currently it says current the monthly spend is something like this. The general forecast is it's gonna range to something, say like the $100, and then the average is something like this. Yeah. Then if I go to the efficiency, so currently these are the features which is yet to come. So in the sense the cast AI, they are still still integrating the features on this particular SaaS product. Then so basically current month so currently month spend is this one, the forecast is this one. Yeah, average daily spend is this one. Yeah, so basically it gives you complete overview, like how much dollars it's gonna cost. Yeah, so if I go down, so this is computer spend in the sense basically on the nodes level, how much it's gonna cost you. Yeah, that's what the data is gonna show you. And the down the line, so this is like a daily compute spend details will be shown here. Then so if you go to the normalized one, so this is what the data on demand, fallback, you can see these are the options. And then the spot details will be presented. So these are like a very depth concept. You might need to explore more about these options. Yeah, I will go to the workloads. If you go to the workload, so on the workload, so what does that workloads means? In the sense, on the Kubernetes cluster, we have deployed the applications. Applications are nothing but pods, and at the pod level, how much cost it is being consuming. So that visualization will be done in this workload options. Yeah, so you see there are like each colors will be given to one pods, and their cost consumption graphs is being shown here. Yeah, so if I go down, so you will see the workload level, that is cast AI. Currently the number of pods equal to 1, and then the so then the total cost that it is consuming something like this. In the sense, you can visualize so which pod is actually eating how much kind amount of dollars. So and so not only that, it also tells you how much CPU it is using, how much gigabytes of memory it is using. Yeah, like that. So basically and so the respective. So if you convert a CPU into dollars, nothing but that much amount of dollar it is eating. And the memory, if you convert that memory consumption into dollars, it's gonna show you that. Yeah. So if you summarize these two, so basically that is how in general total cost of the workload is all about. Yeah. So likewise, the number of parts that are running on the Kubernetes are being explored here. Yeah. All right. So I'm gonna refresh this page again. Note that so I have already tried this option. That's the reason so some of the data are getting overlapped. But so let's say if you are doing it for the first time, and with the using the different name, then you should be seeing the exact data. Then it's gonna show you the namespaces. Currently, our cluster has 2 namespaces. I'm gonna show you that as well. So if I run the command called kubectl get ns, so we should see the 2 namespaces, which is basically so it is currently it is discovering the cast AI, and the other one is basically that is the cube system, which is actually contributing to the dollars, and that's what been discovered here. Yeah. All right. So I'm gonna go to the another options, that is allocation groups. So we are just exploring the allocation groups, because we have not opted this one. This is not one. Let's go to the savings, availability savings. So savings in the sense, this is the dashboard, which the cast AI helps us. Basically this is like a summary from the cast AI about our EKS cluster, saying like how much you can save it if you opt in the further options that is available in the cast AI. Yeah. That is, if I see the read only, so currently it is in a read only mode because I have not given the access to do the modify the changes in the EKS cluster. That's the reason it says that currently this is in a read only mode. I can save like a 32% of the cost. Okay, so monthly, so which constitute monthly like $59 I can save. Annually I can save like $712. As of now, my cluster does not has any application. That's the reason I can save this much. But let's say in the enterprise grade, you can save these dollars very huge level as well. So this is the current status. That is the current estimate of the cluster is it stands around like $182.21 per month. After using the the available optimization from the cast AI, we can reduce it to something like this, yeah, which is like a 30% save. Yeah. And then if you go to the workload level, we have these kind of parts are been running. Since we have just now installed the agent, it's gonna take certain time. It's gonna populate the data. I'm gonna go to the node list now. So we should see the 3 node list, and so these are the node list, and you see the type is currently it is that is a T3 large. Yeah, we're gonna see like if after enabling the cast AI capabilities on this on our EKS cluster, currently it is read only, which is nothing but it's just scraping the data from the EKS cluster and visualizing and giving you the summary. Now let's authorize the cast AI to modify or re-architect our EKS cluster, or modify the EKS cluster to save the cost according to its calculation. We're gonna say that the node type gonna changes. So how does that happen? We're gonna see it in a couple of minutes. So this is the security report. So if you see, the security reports are being getting generated here. All right. So I will go to the available one. So I will just say like start now. So what is the next option? Okay. So right now I have shown you how to integrate the Amazon EKS cluster with the cast AI. And then finally I have walked you through the dashboard, like how does the data it gonna populates. Now we're gonna say what we do is we're gonna go to the next step, that is allow the cast AI to do the modification on the EKS cluster so that it's gonna save the dollars. Yeah. So note that this is purely I think it is recently came in product, so you need to do a proper POC and use it for the production. Okay. So I'm enforcing on the point, so do a rigorous analysis on your lower environment, test it, then use it for the productions. So I'm gonna go to the to the node list. So what we can do is we're gonna enable the cast AI on the node level so that it's gonna help us to save certain dollars. Okay, so if you go to the savings available, and I'm gonna go to the start saving now, it's basically what is telling is enable the cast AI to get advanced Kubernetes automation and cost monitoring and deep security insights. Okay, so basically we are actually elevating our thing, but we are enabling the cast AI agent so that we are actually elevating its permissions to do the the advanced Kubernetes cost Kubernetes automations and the cost monitoring options, and deep security insighting will be available. Yeah. So this, as you see here, so basically ready-made commands are being populated by the cast AI itself. I will go back to the node list. it actually goes to the same page actually. So nothing but what has happens is currently we have just integrated it with the read options, but now we are giving certain permission, that is contributor permissions on your EKS cluster, to get the advanced Kubernetes monitoring automations, and then get the deeper security insights. Yeah. So to do that, since as I said, currently I'm in a Windows system, I'm going to copy this command and run it, but we have a problem because we are Windows. So I'm going to show you this command. If I hit it, basically it says so it does not works here. And if I go to the even I go to this one that is in the PowerShell, it also does not works. So for that case, what I was to do is I was to go back to the my cluster. This is Amazon, right? This is my AWS account. So I'm going to go to the Cloud Shell. So Cloud Shell of region Oregon, that is nothing but the region where my EKS cluster is sitting fine. Yeah. All right. So here, what we have to do is so basically it's loading my session. I have already previously did a certain job, but here note that if you are using the if you are using the AWS Cloud Shell for the first time, you need to install two softwares in this Cloud Shell. One is kubectl, you need to install the Helm. Okay. So to do that, I'm going to tell you those commands what you need to run. I have already articulated those commands in the helm-file.txt file. Anyways, this file will be shared in my GitHub repo, and the GitHub repo link will be provided in this video's description. You can find it from there. So we're going to first one install the kubectl, then install the Helm as well on the cloud, on the AWS Cloud Shell. Then we're going to run the command which is shown in the cast AI. So I'm going to run this command. So you don't need to worry. Basically, these commands, I have articulated in this txt file, and I will gonna share that txt file as well. Yeah. So I'm gonna hit the next couple of commands to complete my kubectl installation. All right. So then I'm gonna go to the next command. So these are the commands which AWS tells us to do if you want to install kubectl on the Cloud Shell level. So we're gonna run the next commands. So basically, if you run these three commands, which means that you have successfully installed kubectl. To check that, you can just run a command like kubectl and hit enter. It should show something like this. Yeah. If it is showing something like this, which means that kubectl commandlet is already installed in our Cloud Shell. Similarly, let's go to my next command, that is how to install the Helm. To install the Helm, we need to run the three commands, but before that, make sure that you have installed the OpenSSL. So to do that, basically what I'm doing is I'm gonna run the command like this, that is sudo yum install OpenSSL. So I'm going to run the command. So what does this mean? In the sense, what does this mean is we are installing the prerequisites which is required to install the Helm. Yeah. With that note, I'm going to go to the next command. That is the next three commands are specially mean for installing the Helm on the Cloud Shell. Or you can reuse the same command and you can install the Helm on the Linux system. Okay. So these are mean for Linux systems. Remember that. So first one is to download the sh file. And then we're gonna go to the next one, that is change mode command, that is just to run the script basically. I'm gonna do that quickly in a couple of seconds. So we are basically running those 6 commands one after the other, and then yeah, all right. So I'm gonna run the next command, that is basically to install the Helm. Once this is done, you can check the command like Helm. It should respond something like this, which means that Helm is being recognized. Yeah. So not only that, so we have to set the context of the AWS account, and then set the context of the the Amazon EKS cluster, right? So for that case, I need to run a command called AWS configure, because by default the session will be loaded with the session that you have logged in. I have logged in with the root account user, which is basically not allowed to set the context of Kubernetes cluster. So for that case, what I do is I'm going to run a command called AWS configure, and I have already set the commands previously, so that's the reason it is taking my previous session credentials. I'm going to keep those defaults like I did it in a Windows CMD. Alright, so with this command you can check the context if it is set or not by running a command called AWS STS get caller identity. So I'm going to do the same thing, and then we're going to run the command, that is so I'm going to run this command. Alright, so the context is rightly set. Now we are set to run the cast AI command to enable the cast AI to get these data. Yeah. So for that case, just copy this command and then go to the cluster Cloud Shell option here and just do a copy paste and run the command. Right. So what I did is, so I did prerequisite configurations. I did install the prerequisite softwares, and then I enabled the context. Yeah. So I think this is not yet enough. I need to set the context as well, which is I have left. So basically I didn't set the context of EKS cluster. So to do that, I need to run a one more AWS CLI command, because so it has to update the kube config, right? So without that, the context of our Kubernetes cluster will not be set. So for that case, what I'm doing is I'm just running a command called something like this, that is update the kube config, right? This is the command, that is AWS EKS update kube config, and give the cluster name. If your account has the access, then automatically the kube config file will be created in your session. That is what I'm doing. So this is actually we need to set. Then you can run a command called kubectl just to check whether the kubectl is working or not, like kubectl get nodes. So it is responding. So which means that we were able to successfully interact with the EKS API server or Kubernetes API server of our cluster. Now what I do is I'm going to run this command. So like this, I'm just copy this and going to run this. So let's say if you are having a system is Linux, which is very forward, it's just a one-step job. Yeah, it's not such a big, right? Since I don't have the prerequisite, that's the reason it is taking too long. But let's say you have all prerequisites been set. It is just a one command job to do the next, to do the cast AI integration for the elevated job done. Okay, so basically you are elevating the cast AI agent to optimize our cluster, right? So first, by default, when you install the agent, it just gives a reader permission. But if you want to elevate the cast AI to make the cost optimization, to make the optimization for your EKS cluster, then indeed you have to run the next command. That is what cast AI tells us. So as you see, so basically it is a very lengthy job. Basically, if you see, so what does this command tells? If I can tell you while it is installing, it is nothing but if you see here, it is running one .sh file, which is nothing but a simple shell script file, which I can show you in the internet as well. So if you go to the internet and just search this file, so this is nothing but just a bash file or shell script, and those shell script commands is nothing but it is doing certain jobs. Yeah, and that's what here it is doing basically. So it is doing a couple of options, it is doing a couple of checks, and it is finally updating the agent as well. So with this, if you go back to the cast AI and say that yes, I have run it, right? So it happened in a magic, and it said that enable the cast AI to get it. So basically we have enabled the cast AI to get advanced Kubernetes automation and do the advanced Kubernetes automation, and cost optimization has been done. Then the enable the deeper security insight is also been done here. So I'm going to mark it as a done. So whenever you have integrated the cast AI like that, so you see the other options saying like rebalancer auto audit logging gets automatically enabled, right? So earlier these two options were in a disabled state because at that time you were a reader for the cast AI. Yeah. So now we go to the node list and we're going to optimize it. Okay. So right now it does not has anything. So earlier it used to pop up, right? So since we have did the elevated access configuration, it has gone now. So we can do the cost savings. Okay. So if you go to the available savings options, automatically it shows you something. So it shows you like hey, you can do this kind of optimization to save the certain tasks. Yeah, or to save the certain percentage of the cost, you can save it. Yeah. So the current cost of my cluster is very high, that is $182 dollars per month, and it says so basically you can reduce it. Yeah. So how to reduce it? So that is where the rebalance option is telling us. So what I do is I'm going to do a rebalance. So this is where let me let me provide a very cautious note here. This is actually basically you are telling a cast AI to restructure your complete the complete EKS cluster. So be careful and not do it in with the required care here. Yeah. So I will just say like regenerate plan. So I'm going to say regenerate plan. So basically we are running a rebalancing here, right? So currently it is regenerating the plan, and in the plan it so it says it has generated a rebalancer plan saying like rebalancing moves the selected nodes from blue to green state, realizing say there is a savings in the process. Yeah. Nodes in the red mark cannot be migrated because they contain certain problematic workloads, right? And the nodes marked in a gray were not selected for rebalancing. Yeah. So if you see here, there are so there are like certain optimizations here. If you see here, this is like so currently there are like if you see here, there is a red mark, and if I go back to the optimizations, yeah, so currently this is the what it's showing, and you refresh it, basically it is still getting the data. for your information. So cost optimization, let me rebalance again. So actually, so why it is not rebalancing is basically, it is telling, autoscaler is disabled. So autoscaler is a one more option within the cast AI which will help us to rebalance. To do that, you have to go to the autoscaler options and then set up the autoscaler, full cluster autoscaler. So cast AI manages the entire cluster, in the sense manages all the cluster resources efficiently, achieve the biggest possible savings out of the box. Yeah, so blah blah. So I'm gonna just set this up and then enable it. So basically it's currently enabled, you see. So basically if you see this mark, which means that it is currently enabled. Yeah. All right. So with this node, if you go back to the this one, yeah, now you see the rebalancer has changed. Yeah. Earlier it was not giving us an option to check what it can do. Right now it is giving something. Yeah. So if you go to the active, so this is currently active. And so it says, it has an option saying like a schedule the new rebalancing or prepare a new plan. So basically I will just instead of scheduling is, it's just like as if you need to schedule the rebalancing based on your business conditions, you can do that. Or if you want to rebalance right away, you can do a one more time plan. So basically I'm running the rebalancing plan again. Right. So before, while it is rebalancing, let me show you that, currently we have, if I can rerun the command, that is kubectl get nodes. So we have a 3 nodes been rerunning and all are T3 large, which is higher in the memory size. And the cast AI will analyze and it will tell an opportunity to rebalance it. Okay. And that is what it happened. So earlier we were not enabled the, we didn't enable the autoscaler. That's the reason it was telling, it cannot do anything because it was in a gray. Now, or it was in a red basically. Yeah? So if you see, right, rebalancing moves the selected nodes from the blue to green state, realizing that there is a savings. Okay, so nodes marked in the red cannot be migrated because they contain the problematic workload. Yes, earlier it was problematic workload because autoscaling was not enabled. Now it is in blue, in the sense this is the existing one, and that could be converted into a green, which is actually gives you some certain savings. Right. So if you see here, we are actually restructuring our cluster from 3 nodes to 2 nodes. Not only that, we are actually restructuring the node configurations as well. Here it has a 2 CPU 8 GB. Now it is telling us to, hey, get a node of type like C6a.large. Currently it is T3.large, which is greater than that. And eventually, so we are actually, it is also telling, to keep only 2 nodes with this configuration, and eventually we are saving this much amount at the first stretch. Yeah. All right. So this is what actually, that is the, the powerful nature of the, the cast AI, which will helping us to, automatically rebalance and achieve the, the cost optimization. Okay. So I just clicked on a button called rebalance, and it will show you the live, the status changes. Yeah. So while it is running here, I'm going to show you the, the status of the, the nodes getting changed. If I see that on cloud cluster, that is kubectl get nodes, you're going to see the nodes number getting increased. Right. So if I go back here, so currently it is preparing, you see the rebalancing is in progress, creating the nodes, draining the nodes, deleting the nodes. Okay. So it's basically, it tells you lively, what is it doing. Yeah. So you don't need to check like what I'm doing it here. But to learn the cast AI, you can do the same thing. Yeah. So I'm just going to hit enter. Here it goes. Earlier we had a 3 nodes. What it is doing is, it is spinning up a 2 more nodes, and it is trying to clean up the T3 nodes. So basically what is happening is, remember that it is doing a magic backend. So in the sense, it is creating a new nodes with the lesser configuration than the existing one, migrating the workload to that particular, to that particular nodes, and then it is cleaning the, higher configuration nodes. Okay. So how did it came to know that, it has to do that? That is what the cast AI intelligence is telling. Yeah. So backend, they are using the, artificial intelligence from the backend, and that is indeed helping us to, restructure the cluster so that we have a certain savings. All right. So, and make a note that, so you need to rebalance when you really have analyzed that, it does not impact your application. Indeed, the cast AI will also have a capability to analyze that. But as the real application owner, that, how does your application behaves based on the user consumptions, based on, you need to take a call, and also based on your call, you try to use a rebalancing. That is my suggestion. Yeah. Not like, directly jump for the rebalancing, but take your business use case and then try to use the rebalancing. Yeah. All right. So we have done with the rebalancing here, saying like, the original nodes were successfully replaced with the optimal one, and henceforth reducing the cost. Earlier it was like $182.21 per month. Now it is restructured, and it will help us to save this much amount, that is 38% is saved, right? Then you see it has changed from 3 nodes to 2 nodes. Okay, that is what I was telling. So the cast AI has a capability to help us with a great extent. So not only just like not only just like a suggestion from the dashboard, but it also has a capability that that it can help you to restructure your cluster, make it optimal configuration, and eventually save the dollars. So if I check the the nodes, currently we have a 2 nodes. Earlier it was 5 nodes because it was spinning up a new and deleting the old one. Yeah. All right. So with this, so we have successfully achieved something notations. Now I will go back to this, back to the reporting options. Now right now, you see that current compute cost is this much. The autoscaler policy enabled equal to this much. Yeah, the progress optimal is this one. So like this, it's just a cyclic process. It will keep on evaluating the cluster, happenings, and it will try to identify, how much more you can save it. Yeah. All right. So I will go to the other options. So you see the configuration comparisons. Yeah. And also it is potentially, it also showing that hey, not only that, you can also save further. Okay, so it is like, as I said, it is cyclic process. It will keep on identifying optimization opportunities on your EKS cluster, and it will also help you to restructure according to its identification. Yeah. All right, so I will go to the node list again now, so to show you that it is now currently it currently has only 2 nodes, and the nodes type is changed to ca.large. Earlier it was t3.large. Now it is ca basically c6a.large, and the price is which is lesser than the t3. Yeah. And then if you go to the security options, so there are security options are also been possible here, which I have not explored, but I have explored more on the cost perspective. We have a node templates, you can use that. We have the node configuration which need to be explored, and then you again have the rebalancing options. Okay. Then you can prepare a new plan as well, so you can build a new plan. Generate a plan. You can also, if you rerun, so this is a second stretch that I'm running, and it also calculates if there is another possibility to restructure. Basically, here you go. So basically, it telling that so from this to this one, that is from the blue to greens, currently this is the cost, and it is not, it is telling that currently this is the currently we are already in an optimal size. It is helping us to keep the number of nodes equal to 2. But if you see here, we're actually changing the parts to 4, and the CPU memory are also getting minimized. Yeah. So like this, so this is like a continuous process. The cast AI is helping us to achieve the the optimization levels. Yeah. If I go to the dashboard, you can see very nice dashboard, which is giving you soothing one, because you are shaving the cost here. You are saving a cost a lot. So if I can refresh it here, it is the current status of your EKS cluster. It contains 2 nodes, right? And it has this much parts details. And eventually in the cost monitoring, if you go to the cost monitoring, so you have the lots of savings been shown here. And if you go to the workload levels, so the workload level will still remain same, because we have not deleted the workload levels, and the namespace will also remain same. But basically by using the the saving plans, you actually saved the reserved the compute option savings are being achieved by using the rebalancers. Yeah. All right. So like this, we can leverage the the cast AI to optimize the cost at our Kubernetes cluster. Not only Amazon EKS cluster, but also you can use it for AKS, you can use for GK, you can use for OpenShift. Yeah. So there are multiple options it does provides for us. Yeah. All right. So with that note, the things need to be shown in this video is successfully shown. Finally, so I'm going to upload those commands in my GitHub repo, and the GitHub repo link will be shared in this video's description. You can find it from there. Finally, a kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot, and see you in the next video.